So for today's lesson, we're going to be starting what's called systems of equations. Up until now, whenever you guys have been solving equations, it's usually like solving for x and then getting the y answer, or maybe working backwards. Now we're going to introduce you to systems. We did it in Algebra 1 last year, but it is a topic that is quite often missed. And so we have equations with x and y equaling a number, and you have to graph them, you get like all this crazy shading and different solutions. And it's the way we algebraically solve for more than one thing that we don't know. Up until now, it's always been solving for x. Now we'll be solving for x and y. However, today's lesson's a lot easier because all we're going to do is take these different word scenarios and turn them into equations and stop there. We're not solving for anything. So it's going to be a pretty fast and easy introductory lesson. The 4 steps we have above are pretty much your basic common sense approach to problem solving. Read the problem carefully. Highlight anything that's important from the equations. What's new is this next 3rd step, define your variables. For today's lesson, everything that we're going to define as far as variables is going to be x and y. So just be ready to have everything with x's and y's only. You can technically use other letters, but we're going to just keep it standard with x and y. And we will be writing 2 equations for every problem up here. So let's go ahead and start with our first one. Here's our first story. Eddie is selling candy bars to fundraise for his wrestling team. He sold a total of 13 candy bars in one day. Some were Snickers and some were Kit Kats. Write an equation based on this situation. So the first sentence, Eddie's selling candy bars to the wrestling team. No math in there, so really no information that we could pull out. The second sentence, though, does tell me he sold a total of 13 candy bars in one day. So that's important. We're going to have total of 13 candy bars. And then it says some were Snickers and some were Kit Kats. So Snickers and Kit Kats. Now, what we know is we need to define the 2 variables. What 2 things are being mentioned in here, but we don't know how many we have.
Snickers and Kit Kats.
So we'll call one of these x and the other one y. Typically, I like to go in order from left to right. Whatever I see first would be x, second thing would be y. It's just a good standard form. Although technically, if you really want to, you could mix them up and it doesn't matter, but let's just keep it in order. So now, the word total up here, that implies a very specific math process. And what math has to happen to get a total? Adding. So if we added up the Snickers and we added the y's to that, we know we have a total of 13 candy bars that were stolen. Do we now have an equation that models the situation?
Yes.
Yes, and that's where we stopped for part 1, because that's all we were asked to do. So now let's take that same information and apply it to part 2. The number of Snickers bars he sold was 1 more than twice the number of Kit Kat bars. So if we read it again, let's translate it. The number of Snickers bars. We define Snickers bars as what letter? X. So I'll begin with an X. The amount of Snickers bars he sold was. Was is a nice way of saying equal, in the sense that it's comparing Snickers bars to some other thing. So it's like the middle or the equal sign in our equation. It's like the stuff that compares one side to the other side. It's comparing it to 1 more than twice the number of Kit Kat bars. Mathematically, what would 1 more than look like? Adding how much?
1.
So I can take 1 and add it to something and I would have 1 more. 1 more than twice the number of Kit Kat. What does it mean to twice something? Multiply by 2. And what are we calling Kit Kats? Y. So 2 times y. Or in other words, 1 more than 2 times y. Have we written an equation now? And that's all we have to do. Questions on this first part 1 or part 2? All right, let's go ahead and go to the next one now. Now we have a geometry problem. Christina is remodeling her house and built a rectangular closet for her room. The closet has a perimeter of 24 feet. If we reread it again, we know we have a rectangular closet. Let's take it back to middle school and even elementary school. With rectangles, we know we have two dimensions. Those dimensions are referred to as the what and the what?
So with
And the length.
Length and width. Usually we say the longer side is L and the shorter side is W, and it doesn't really matter, but we'll stick with that. However, we did define the rectangle into two variables, but I want to keep it algebraic. So I'm going to call all the L's the same thing as X, and all the widths the same thing as Y. And on any given math test or math problems, they can actually use L's or W's or X's and Y's. It doesn't really matter, but I'm going to keep it standard with the X's and Y's. We also know we have a perimeter equal to 24 feet. I'll come in handy in just a moment. So, talking about perimeter, what does perimeter mean of any given shape? What are you doing to get a perimeter?
adding all sides.
Better answer, adding all sides together. So in a rectangle, what sides would you be adding, giving me things like lengths and widths?
Just add the lengths together and then the widths.
Add the lengths, add the widths. How many lengths do we have?
Two.
How many widths?
Two.
So do you remember the perimeter formula from middle school? Perimeter equals
Length. Two.
two lengths
Plus two widths.
plus two widths. Let's change it back to X and Y. So the two lengths we'll call 2X, the two widths we'll call Y, 2Y, and the perimeter we actually have an amount, don't we?
Yes.
24. So we now have an equation that models this scenario. We almost had a problem if we kept it in the first form because we would have had L's, W's, and P's. We're not up to 3 letters that we don't know. We're only practicing the 2. So we had to have the perimeter, and thank God they gave it to us, so it's 24. Now that we know length is X and width is Y, the length of the closet was 8 feet less than 3 times the width.
So minus
So we know the length of the closet, what letter is length?
X.
X, was, acts like an equal sign. Now here's the catchy part. Looks like it's a little difficult for some students. 8 feet less than 3 times the width. I think we can all agree that less than implies what kind of math? Subtraction. The question is what order? Now we know 3 times the width. How would you write 3 times the width?
3. Y.
3y, okay, so now, are we gonna say 8 minus 3y or 3y minus 8? Which one of these, now this is a word issue, this is a language thing, is 8 less than 3 times the width?
It would be.
And if you're not sure, here's another way we can do a little mental thought experiment. What if I said the total number of Algebra 2 kids that I have is 3 times this class, or 8 less than 3 times this class? What would you do first to figure that out? Would you take 8 and subtract 3 times my class sizes? Or would you take 3 of my class sizes and then subtract 8?
Subtract 8.
So choice 1, how many think it's choice 1? How many think it's choice 2? The answer is choice 2. You have to know what 3 times the width is before you can do 8 less than that. The catchphrase here is less than. In every example before we got to this one, if you just went from left to right, you were able to plug in everything literally in order into our equation and it worked perfectly. Less than is a tricky one. It does mean subtraction, but it means you're going to switch the order that you read. So whatever comes before less than will be after subtraction, and whatever comes after the word less than will be in front of the subtraction sign. So if you need to make a little note for yourself, maybe a little star, my stars are all jacked up. Less than has like a reverse order kind of policy going on. If it just sounds natural to you and you figure it out easily, then just stick with your own thoughts and no need to make it any more difficult. So we now have our equation that represents this situation. Our final example now. Andrea and Noah were working on their math homework. Together they answered a total of 15 math questions. Andrea answered 3 less than twice as many as questions as Noah. Write 2 equations that represent the situation. So we know we're doing systems, we need to have 2 things that are being measured. In this story, what 2 things are being measured? Andrea and Noah. So we'll just go X and Y. They're doing homework. And they're doing math problems, so we can assume that we're talking about the number of problems each one did. We know together they answered a total of 15 math questions. So using the X and the Y and the 15, make a math sentence out of that. We know the word total was in there.
X plus Y equals 15.
Very good. Whatever Andrea did plus whatever Noah did equaled 15 questions. So there's the first of 2 equations. Now our third sentence here says, Andrea answered 3 less than twice as many as questions as Noah. That means weird. I think we know what they mean. So let's start with Andrea. How are we representing Andrea in this story?
X.
And then we're talking about what she did compared to Noah. So we're going to be equaling because we're talking about Andrea in terms of Noah. She answered 3 less than twice as many as Noah.
So it would be 2Y minus 3.
Very good. Twice as many as Noah with 3 less taken out of that. Do we now have our equation? That's all we were asked to do. That is your notes for today on this topic. Are there any questions? Excellent.